about 180 cumulative questions, and the first time he emailed it to me, it didn't go through at all, and I had to make him like re-email it. So I'm pretty sure what ended up happening is that he tried to post a file on Files. It was too big, it didn't upload, and he will definitely be giving that to you by Monday. I will make sure started. Some of you guys have a survey. If you guys want surveys, they're probably going to be at the end of the row. When you guys are marking these, my session is number 9, but we have to mark 09. So just make sure that you guys have that evaluated. That's just so you guys can kind of see how I've been doing and share your opinion with mostly Sark. All right. So these are my last ones. So from 10:30 to 11:20, this is Business Administration 1, the second floor, and this is Classroom Building 1, first floor. If you guys need help on how to get there, you can come see me afterward. All right, so what I've done alarm set to 3:45, which is 15 minutes before the session ends. We'll try to go through as many as we can. I'm going to be up here. If you guys have a question, just raise your hand and yell out questions so I know to look up. And feel free to ask whatever you guys want. Again, is the Tuesday review with me? And that's a great question. So basically on Tuesday, Trin is going to have her session. Do you have the times? I think it's 5 to 7. Okay, so on Tuesday from 5 to 7, there will be another Chem 1A review. It is with your Chemistry 1A tutor. All right, any more questions? Yeah. You would have to check the SU schedule for that one. That's a good question. Cape Florida, A, B, C, D, from 5 to 7. All right, any more? All right, can you guys see that okay? I know it's a little bit small. I need space these out though. Are we okay with seeing these? Again, he's gonna post them, so in case you just wanna write down that this is number 14. So for this one, it is asking, what is the mass of carbon contained in 37.1 grams of caffeine? So this is going to be a percent mass question. We have to remember that if we have percentages, they're going to be out of 100. So we know that there are, from this percentage, there's 49.47 grams of carbon per 100 grams of caffeine. When you guys do this ratio here, this should give you 18.4. You want to start out with the number that you're given of a sample, and then you want to remember that all these percents are going to be out of 100. So that's a good point. It's going to be all right, we're all on the same page? Yeah? All right. Let's go over 15. All right, so the reason I'm going to be doing a density question is because a lot of your molarity questions so here it says that a metal cube has this much mass, and we drop it into a graduated cylinder, which is used to measure volume. So it usually has 30 milliliters, and it rose to 39.5 milliliters. So we always want to remember that we're doing final, which is 39.5, minus initial, which is 30. Grams of our sample, which is 112 grams, over this change in volume, which is 9.5 milliliters. This should give you 11.8 grams per milliliter, giving you enthalpy. Again, the reason I'm doing any questions on this one? Cool. All right. Let's go to, everybody got it? Anyone still need it? Raise their hands. This is number 15. Is it kind of hard to see with the All right, any more questions on this one? All right, let's go to number 18. He said to is how much heat is released as the temperature of 25.2 grams of iron is decreased 70 to 9.8, and it tells you the specific heat of iron. So we want to remember here we have mass, here we have a change in temperature, and here we have a specific heat capacity. So when we're doing this, we just want to do Q equals MCAP. Even though it says that it's decreasing from it, we're used to having an increase in temperature, but we still have to remember that whenever we see delta, it's going to be final minus initial. So here it went from 72.1 to 9.8. So our final would actually this is just going to be in grams because our specific heat and our specific heat capacity is in joules. So this is going to be 697 joules. However, as you guys can see, all the answer choices are technically in kilojoules, and there's some joules, but those are incorrect. So it just wants a quantity. Obviously, when we release heat, this is going to be a negative exothermic reaction. So don't get flustered by all of these negative. Just remember that the question kind of implies that it's going okay. And let me get number 20 for you guys. chose the hardest ones of the review, so as you can tell, it's not too bad of a review. I would definitely make sure to go over his old test. And if you guys have absolutely any questions on his old exams, like you can't figure out why an answer is a certain way, so here we have a 10 kilogram piece of metal at 50 degrees Celsius placed in 1,000 grams of water at 10 degrees Celsius. So the metal and water come to the same temperature. What's this going to be called? What do we usually call this? Bless you. Equilibrium. And as you guys remember, his tests are kind of literally 50-50 concept and math. So as much as I would study the math, I would also study the concept questions as well. All right, so let's get started with this one. We have to remember that whatever happens solution that has a density of 1, which is water. Whenever we're plugging these in, we have to remember that Q is going to equal MCAT and that this is going to be in grams. So the first thing I want to do is convert the first number I see from kilograms. One kilogram is going to have 1,000 grams. And when you do this math, that's going to give you 10,000 grams. All right, so here we want to do MCAT equals and the temperature change. So for this one, it says that the metal started off at 50 degrees Celsius and it was 30.6. So we want to do that final minus initial. So 30.6 minus 50. And then we 1,000 grams of water times the water was originally at 10. I want to do 30.6 minus 10. And then he tells you this one in this question, but we should all remember that the specific heat of water is 4.18. So when you work so we want to divide this by 194,000 negative. And when you guys get to this part, this should equal 0.444 joules times grams times degrees Celsius. Our previous example, it's going to be kind of the same specific heat capacity. So here you're given a lot of different variables. If I were doing this review, like if he had given a question like this, I would have done it. Like what's the final temperature of them? Again, it's just kind of algebra and knowing where to put all these in. Questions on this one? All right. Does anyone still And just so you guys know, the reason I can't post his review is because these come with answer keys, and I am not allowed to post up answers in general. So is going to be number 22. Um, with Celsius, but once you guys get to Chem 2, the majority is going to be in Kelvin. So you just have to remember that to get Kelvin, you just add 273.15 to your Celsius. So in this case, the question is negative 53 degrees Celsius, bless you, and your Kelvin should end up being around 220 Kelvin. And if you guys give me 1 second, I really want to give you this chart before I go. Where is it? And you guys have it in your textbook. I have the second edition, so it's obviously going to be a different page number, but I would definitely make sure that you guys look up the chart on naming compounds. Or else that's like 100 points off your grade. Your textbook, the e-textbook will be part of Mastering Chemistry, so don't feel like you have to buy it again. Because for the next couple of questions, it's just on naming compounds. So again, I feel like a chart would be self-explanatory for those. So let's move on to like one of those silly ones that I don't really like to go over, but on the answer key it says that this is one of the challenge ones, so we'll just go over it. So if you guys see here, it says a sample of ethane contains a total of 16 N atoms, where N is 6. If he doesn't, you definitely need to have that conversion factor. So it says how much ethane is in the sample. All right, so if you guys kind of see here, we have 2 carbons and we have 6 hydrogens, so this is going to give us a total of 8 atoms. Hold on. Then we know that this is going to have 2 moles of C2H6. Because there's 16N, but there's 8 atoms, so we just want to divide this 16 by 8 to give us 2. That's how much we have. How many moles of it? As you guys 2 grams here. Carbons weigh 12 each, and hydrogens weigh 1, giving us 30 grams in 1 mole of ethane. When you guys do that stoichiometry, this should give you 60 grams, and it's going to be C. So again, this is kind of one of those tricky ones. If you guys get stumped on one, so yeah, just make sure that you have, if you guys have questions, to ask a TA rather than get a question wrong. Any questions on this one? Yeah. I haven't tried that. Try that and you get the same answer. That method, I'm not gonna delve into that. It if that makes sense. Any more questions? Yeah. Okay, so when we have any compound, we usually have, in this one, we have 2 carbons, hydrogens bonded, so that's going to give us the 8. That's a good question, though. Yeah. We have 16 N atoms, and then here we have 8 atoms, so we want to just do that 16 over 8. All right. Yeah. That's up to you, though. I don't really quite understand that question. I'm sorry. Again, I wouldn't stress out over these. Again, it's just a challenge problem, and I want you guys to see where we get the answer so you're not like super confused. All right, let's move on to number 30. All right, these I would definitely worry about, mostly because we spend a lot of time in class with them. And this is going to be number 39, and we're still on exam 1, or part 1 of the review that he's going to talk to you guys. So this is going to be empirical formula of the compound. But I hope he just gives you one like this. So it says that we're completely combusting 0.15 grams of a sample, and we can measure how much carbon dioxide it has and how much water it gives us. So just from this game plan, what we really want to do is that we want to go to mole of carbon to grams of carbon. We want to do the same thing when we get to the water. And you might be wondering here, we know how much grams of carbon and we know how much grams of hydrogen. How are we going to know how much oxygen we have? That much water. So whatever we get for these values, we're going to subtract that from the 0.15 gram of the sample minus our added grams of carbon and our added grams of hydrogen. All right, so this is the game plan. Does anyone have any questions on this one? I know we had a lot of difficulty kind of Okay, awesome. So we have, I'm just going to start off with dioxide as it's kind of first. So I have 0.0 of CO2 as 44 grams. Carbon has 12 grams of carbon. When we this is going to give us 0.0614 grams of carbon. And then we're going to do the same thing we did with our carbon dioxide, and we're going to do that to the water. Grams of water, and in 1 mole of H2O, this is going to be super important and it will kind of trip you up in these problems. We just have 2 moles of, so make sure that you make that point. And 1 mole of hydrogen has 0.7 grams of hydrogen. So we've already carried out the first game plan, the second one. Now we want to find out how many grams of oxygen this has. So what we want to do is this 0.15 minus this 0.0614 plus this 0.00687. How much oxygen I have, which is 0.08173 grams of oxygen. All right, any questions? This coming back a little bit? All right. So now that we know how much grams of each of these elements we have, we kind of want to go back to so 1 mole of carbon has 12 grams of carbon. 1 mole of hydrogen has this many grams. And then for oxygen, 1 mole of oxygen has 16 grams. So again, we switch these all to moles, and 0.0051. For hydrogen, I got 0.0068, and here I got 0.0051. So here we want to, so always remember this. This is kind of 0.00682. This should give you C 0.75, H, and then O point. However, or molecular equation, you want to make sure that you make it a whole number. So this is going to give us C3H4O3, and that's going to be answer choice D. Yeah. For that one, I think there was an extra 0 in this one. Sorry, guys. All right, any more questions? Anyone need more time copying this? Yeah. I'm sorry? Oh, because when we have 0.75, 0.25, to make it a whole number, we have to multiply these by 4. If we have something like 0.33, does that make sense? Cool. We were just dividing by the smallest one here, so we the grams of that. All right. So now we're moving on to the second part of the review. So if you guys see here, he's going to have like a whole by saying that this is going to be part 2. So make sure that you make a note of this. Yeah, we've transitioned to part 2. So I'll just make a note of that here. And this is going to be question number 4. So when you guys get to this one, this is just going to be balancing. Can you guys see the subscripts, or do you guys want me to write it bigger? Oh, you're fine? All right. So here we have lead nitrate. I'm going to start off by saying that we have let's start off with the nitrates. Since kind of like our leads are already balanced, we can do our nitrogens. So this NO3 is going to be nitrate. This NO2 will be nitrite. Bless you. What we do is balance this one out. So we want to change how many oxygens I have on this side instead of going in and adding these. So here we're going to put a 2 in front of the lead nitrate, and then in this part, now I have how many nitrogen. And then when I'm balancing everything else out, now I have 2 PBs, so I want to put a 2 in front of here. And I want to see what that gives me now. So I have 6 times 2, so that's 12 oxygen on this side. And now I have 8, 10, 12 oxygens. So I'm balanced. And for this question, whenever he's so make sure that you read the questions, like especially these, as carefully as you can. So the answer choice is D for 4. And again, you guys can just kind of double check your work on these and kind of see which one would make the most sense as well. All right, make sure that everything is equal on both sides. All right, so we're still going to be on part 2, but we're going to go to number 8, which is going to be this one. Where are you? Here you are. All right, so this is going to be part 2. Equations. How many grams are required to burn this much propane molecules? So whenever you're doing these, you want to make sure that your equation is balanced. As you can see, he's given you guys more space. So let's balance this one. First off, I like to multiply this by 4. When I get this, now I want to see how many oxygens I have. So now I have 3 times 2, that's 6, and then I have 4 times 0, which is 4 oxygens, and this is going to give me 10 oxygens. And I have 2 ones. You're comfortable with writing them. So if he says that a certain molecule or compound is combusted, so let's say that he just gave you that propane is burned in oxygen, you should be able to write out your own equation and make sure that it's balanced and do stoichiometry with it in the case that you need it. All right, so here, whenever 3H8 molecules. All right, so now that you're at molecules, you can go to moles. So 1 mole of anything is going to have 6.022 times 10 to the 23rd molecules. How many grams of O2 do I need? So I want to convert how many moles of propane do I need to have how many moles of oxygen. So in this case, in my balance equation, I have 5 moles of O2, and then 1 mole of O2 has 32 grams of O2. When you guys follow out this stoichiometry, it should give you 79. questions? All right. Let's go on to number 3. Has such comprehensive concepts for this one. It's asking that if I have 58 moles of NH3 combusted with 32 moles of, combined, not combusted, sorry, with 32 moles of sulfuric acid, what is the limiting reactant and how much of the excess? Once I have that settled out, whenever you guys have these polyatomics, you kind of want to leave them alone. So if I have one sulfate, then sulfate, and then we want to see if our hydrogens balance out. So if I have 2 times 3, and here I have 8 hydrogens, so I'm just going to be balanced there. So now that my equation is balanced, I can find all of this good stuff. So here, I'm going to start off with the first number that's given to me, which is 58 moles of NH3. So once I go to this part, I want to see how much this 2 moles of NH3 for 1 mole of NH4 to SO4. And then I'm going to do the same thing with my sulfuric. So here I have 32 moles of H2SO4. And 1 mole of H2SO4 is going to give me that 1 mole of NH4 to SO4. So when you guys do this math, this should give you 32 moles of your product, which is NH4 to SO4. And then this reactant, and I have that much of that reactant, how much product can be made? So obviously this is going to be the smaller number. So the smallest yield is going to be your limiting reactant. Cannot proceed further because there's nothing else or nothing left for it to react. So it's saying which one is the limiting reactant, and now we're stuck between, we can cancel out A and E. So how much excess reactant is left. So for this one, what we want to do is, since this is our LR, that's what we're always going to start off with. Every 2 moles of NH3 combines with 1 mole of sulfuric acid. So here it's going to be 2 mole of NH3. Sorry, that looks, all right, to 1 mole of H2SO4. And this is going to be, so what I just want to do here is I want to subtract the 2. So if my theoretical yield for 32 moles of sulfuric acid is this much, I want to do this 32 minus 29, see how much is actually left over. So this choice for this one would be D. This one. So again, just remember, when you're finding excess reactant, you want to start with your limiting reactant, not your excess. Bless you. So I'll just write a side note. Start with limiting. Cool. All right, let's go. Any more questions on this one? Nice. Let's go on to number 17. Again, if you guys find a question when you're doing this review, how many grams of PI3 could be produced from 250 grams of iodine and excess phosphorus if the reaction is a 98% yield? So that's going to be a really good yield. And what we actually want to do from here is remember our over our theoretical yield. So for this one, it's actually really what's our actual, but we'll get into that later. Whenever we're dealing with percents, we want to go ahead and change that to our decimal. So this would be 0.985 equals A over T. Since we know how much grams grams of I2, and then 1 mole of I2 is going to be 253 grams. And I kind of forgot to mention this one, but we want to make sure that all of our 4 times 3 is on our product side, so on our reactants we want 12 iodines. So now that I have how many moles of my reactant I have, I can get to how many moles of my product I have using this equation. So if I want to cancel out moles of I2, I divide by mole of I2, and my goal here is my ratio, or put it as 6:4, you're welcome to do so as well. If I want to cancel out my mole of PI3, we just divide. So 1 mole of PI3 should give you 411.67 grams. And when you do this calculation, there should be what we theorize that is going to be the yield. So theoretical, we make up the number. For actual, this is going to be given to us. So here we don't have actual or theoretical given to us, so we made up theoretical, and we're going to put 270.337. So your actual is going to be 266 grams, which is going to be letter choice C, and this will be grams of PI3. So again, this is kind of one of the challenging ones because you're not given actual or theoretical, but you can find theoretical like we did here. And in this equation, there's only else you can't really find out the other missing ones. Any more questions on this one? Good? Okay. Does anyone need more time to copy this? Raise your hands. All right. number 28. Mass of NaCl would be required to react with 200 milliliters of a 0.2 molar silver nitrate solution. So to get to this one, we have this equation. So here, my silvers are good, my nitrates are good, my sodiums are good, and my chlorine, so I don't really have to balance anything. It's going to be a 1 have 200 milliliters of 0.2 AgNO3 solution. So for AgNO3, it's going to be our molarity equation, which is going to be mole over big M. This is going to be 0.2 equals, we don't know how many moles, but it does tell us our volume. It tells us our volume in moles of silver nitrate. Once you get to how many moles of silver nitrate you have, you can definitely go and compare basically to any of the other compounds that we have. So 1 mole of AgNO3 will react with 1 mole of NaCl, and then 1 mole or the molar mass of NaCl would be 58.48. That's going to give me 2.34 grams of NaCl, which is answer choice C. I know that there's kind of like another stoichiometry way to do this, but I find this method a little bit easier. So this is going to be of a comprehensive list for you guys. Because the next following questions have a lot about strong or weak electrolytes. So these are your strong acids, anything like hydrochloric, hydrobromic, hydroiodic. We also some weak acids or weak electrolytes are going to be our carbonic, and I think that's kind of one that you have to remember. He didn't really go into these too much. For strong bases, anything in the first or second group is going to be strong, and for base, we have to remember that it's OH with our calcium, with our strontium. It's basically all of group 1 and group 2 with OHs, and anything like strong acid or weak acid, it's more in terms of it being electrolytes, so whether they're strong or weak electrolytes. Lithium hydroxide, you should be able to kind of derive those. Does that make sense? Okay. And our last one would be barium hydroxide. And if you guys want an example of a weak base, you don't really have to remember it, but it's NH3. So again, I kind of went through the next following questions and saw which ones he would. Excellent question. I would definitely ask him on Monday. Since he gave it to you on the first exam, I don't see why he wouldn't. But maybe he wants you guys, like if you have like 4 days off of class, he would make you memorize them. So it's really up to him. I'm sorry? Yeah, he says if a professor says they don't know it off the the top of their heads. I don't feel like he would make you memorize them, but just basically the major topics. Again, if you guys find one in here that you guys are like, I really have no clue, then you can totally come see me Monday class as well. All right. So this is going to be numbers 40. So for number 46, it says that all of the following salts, which of the following salts are going to be insoluble? So when we get to these, we kind of want to remember our solubility rules. Does everybody kind of have the question down? So we kind of want to remember that these are sulfate is mixed with calcium. It's going to be insoluble. So that's kind of how you want to read this chart. If you guys want more of a demo or anything like that, you can definitely come see me afterward. I really hope he provides this for you guys since he did on your other exam. Then I have here silver bromide. So if we look at our solubility rules, it says that, where is it? It says bromides are usually soluble unless Alright, so this is kind of an example of how to read this chart. So it says bromine is usually soluble unless it's with silver. So we already know that this one's insoluble. So we want to make sure that we circle that one because it's asking for which ones are insoluble in water. Alright, when you have are usually just soluble with no exceptions. However, when we get to sulfate, we kind of just did this example. We had sulfate as being soluble, so SO4 is soluble unless it has lead in it. Semester for that. Any more questions on this one or how to read the chart? No? Okay. Which one on? Here? Down? That's going to be C2H3H. I mean, 2 C's, 2 O's, and 3 H's. Does that make sense? It's just figuring it so you guys can remember that it's acetate. I think that's kind of the only difficult part about this one. Does that make sense? Cool. Let's see what else. NH4 plus, yeah, that's going to be what? Okay. You're welcome. All right, let's go on to number 52, and I guess at about 3:45, I'm going to be giving you guys, I think one other chart, and then we'll be done. So much in Chem 1B, but definitely Chem 2. And I want to make sure that we have reiterated the concept of oxidation states. Before we do 52, though, we will want to do 48. that I didn't circle. Yeah, sorry guys. He already kind of told you the equation. He just wants you guys to be able to know whether you ionize something or not. So since we have this as aqueous, we want to write this out as Ba 2 plus. We have 2 Na pluses, and I'm going to have a sulfate here. And when I go to this part, even I still do it sometimes. Whenever you guys see a solid, you don't split it. So this remains as barium sulfate. The reason that it doesn't have any subscripts is because and then we want to ionize this salt, so that's going to be 2Na plus plus 2Cl minus. All right, so this is your complete. Obviously, complete, I think of comprehensive, it's going to kind of include everything that you want or need to know. This question doesn't going to do that anyway. So if you guys see them on both sides of the equation, we want to cancel them out. So the only ones that we can cancel out are our sodium and our chlorine. So our net ionic is going to be Ba2 plus plus a sulfate, giving us our precipitate. So we kind of get canceled out, don't participate. That's going to be Na plus and Cl minus. So again, this question doesn't really go into that much depth, but in case he asks you what are the spectrums for one of those equations, I want to make sure y'all know how to do those. Any questions? Okay. Does anyone still need time to copy it down? Okay. As you can see, I picked out the most difficult questions from his review, so you guys can imagine how easy his review is going to be. Hopefully he makes your final that easy. That would be really nice, for sure. All right, anyone still need time to copy this one down? All right. All right, let's move on to number 52. So this is number 52. Unfortunately, he didn't give you a complicated, an easy one for this one, but it's telling you to determine the oxidation. Split these apart. So this is really NH4 plus, and this is carbonate, which is CO3 2 minus. Whenever we have to make sure that the the sum of the states are going to equal whatever they're, and plus 4 equals positive 1. So this should be -3. Again, he doesn't ask you for the oxidation states of any of the other ones except carbon. I just want to make sure y'all know how to do them. And we know oxygen is usually -2. So 6, not 6, C minus 6. So I know there was a bit of confusion when we were doing the review for this chapter. You do want to split them up and set them equal to their own charges. You don't want to just assume that all of these and set them equal to 0. It's going to get a little. So remember to split them up. Questions? No? Okay. The importance of the hierarchy of rules. So this is number 55. So basically I have K2Cr2O7. So here we're going to have one main group metal, one metals first. And we always are going to keep one variable as x, or one element as x. So potassium is going to be +1, and then we know more about oxygen because there's a set that we're going to look at before the final. It's going to be -2. This does not have any charge on it. -14. This is going to be 2Cr minus 12 equals 0. 2Cr equals 12, and your going to be -6. So that's going to be answer choice C. So again, those. Any questions on oxidation states? No? Okay. I'm just going to give you guys the chart now to kind of avoid time wasting here. All right. For the rest of that review, it's going to be mainly just going through what kind or what actions this is. So if you guys want to get pictures of this, or if you need pictures of any of these by like the end of, if you want to take a higher quality photo, then welcome to come see me in the last 15 minutes. So kind of like I provide the combustion reaction in case he doesn't give you it. And just, I know that they're using a lot of this salt terminology. A salt is just going to be an ionic compound, which is a metal and a nonmetal. And yeah. So if you guys see for the displacement one, we plus BC. Again, this might seem confusing right now, but there's like at least 10 to 15 questions asking what kind of all right. So aside from having, let's see, we did 45 questions, then there's like 80 on part 2. That's provided for you at your textbook if you look it up online. But just so we can kind of go through it, if you have an ionic compound, whenever you guys are trying to name something and you have an ionic compound and it's just a metal and a nonmetal, if it only forms one kind of for our transition metals, that's why he kind of got upset on Friday because he asked about cobalt something. These are the ones that have the just so we remember that. If we have mostly because I believe the hydrate ones and these guys are going to be a little bit different. And then when we get to which are everybody's favorite, if you have just two elements, you just want to use that hydro 4. So that's already going to have oxygen in it. And there's going to be 3 elements, not 2. So we know that we have to use these oxy acid nomenclature. So SO4 is going to be sulfate. So we're going to change that to IC. So that's going to be sulfuric acid. And if we have 2SO, need these for basically everything on this exam, from making equations or if he asks a specific name of something. There was a couple of those in the review, so I want y'all to be comfortable with that. Any questions before we go on to thermal? I'm going to do all the questions I can from to turn in your surveys. And again, make sure that they're filled out 09 and then make a line for questions. All right. The only one that I will not be doing from the thermal part will be number 6. Mostly because you guys learn about bond energies in Chem 1B, and he never really went over. All right, let's start with and let me make sure that you guys can kind of see as much as you can. I'm sorry? Yeah, so this is going to be part 3. He basically sectioned it off into 3 parts. So the first part was chapters like 1 and 2. A lot of time in class dealing with thermal. And he said to make sure that I get through the thermal questions. So if I were you, I would kind of skim over chapters 1 and 2, make sure that I have 3 completely down, and then for chapter 6, sure that I understand the concepts as well as the mathematics behind them. All right, let's start with number 1. So for this one, it's 5,500 kilojoules per mole of octane. So for this one, he gives you a balanced equation. That's very nice. And again, we kind of want to see which one we want to start off with. So I have how much heat is released. That's just telling me how much heat. I'm not sure if he went over naming hydrocarbons with you guys. If you guys want a quick overview and you want to ask me later on, you can totally do that, but I'm pretty sure he didn't. So whenever we have grams in chemistry, we want to change that to moles so we can work better. And this is going to be 114 grams. That's going to be the molar mass of it. It's from it. So 1 mole of CaH14 is going to give me negative 5500 kilojoules. When I do that math, this should give you negative 3,600. That should be answer choice D. All right. Alright, so that's a great point. So a lot of people were kind of confused on the exam, or maybe with this question. We want to make sure that we read the question. We just know that that's going to be one of those exothermic ones, the ones that release heat, so it's going to have a negative delta H. Did that cover your question? Okay. Alright. So it says to calculate the amount of heat released in the complete combustion of 8.1 grams of aluminum to form aluminum oxide and 25 degrees Celsius, 1 atm. You guys should know this number. So again, I have thermo. I probably would start with the grams first and then go to heat. So here I have 8.17 grams of aluminum. I want to make sure that whenever I'm working in chemistry, I change everything to moles. And aluminum's molar mass is 26.9. The enthalpy of formation for my product. So I can go from moles of reactant to moles. So here, if you want to cancel out moles of Al, I want to divide by moles of Al. And I have 4 moles of Al, giving me 2 moles of ALO, Al2. And then here it's saying that mole. Alright. So when you're doing this calculation, you're going to end up with 253.7 kilojoules. And the closest answer is going to be A, which is 254. For chapters 1, we learned about do those rules, because there are questions that tell you to go over calculations and report the answer to the correct amount of significant figures. All right. Any one? No? Okay. Does anyone still need time copying it? Okay. The exam, you're welcome to do so. And I'll do, no, that's going to be kind of similar. I'll do blue and orange for these. Alright, so we're basically asked to find delta H for this reaction, our goal reaction, using these two guys. So we here we see that the only other place that NO2 is going to be here. So if I went from 1, yeah. Oh, okay. I'll just circle and box them instead. Alright, so this says NO2 and this says alright. So what I kind of want to do with this one is I went from 1 to 2 and then I switched the signs. So what I want to do to this number is if this is positive, I want to make it negative and I want to multiply it by 2 here. And that's going to give me negative 6. That's going to give you negative 55.3 kilojoules, giving you E. I don't know why he gave you one of the easiest Hess's law we've seen in class on this review, and hopefully he makes it this easy on the final. That would be amazing for you. Any questions on you a complicated Hess, come see me in the last 15. All right, let's go on to number 4. This is kind of a form of Hess's law where you're trying to find delta H for this reaction, and he tells you the enthalpies of formations for each of these elements. You don't have to know any of these enthalpies. He will definitely give you those. So when I'm doing this, so in this case, I'm going to do, where is it? Okay. So I want to do 3 times negative 272 plus 1 times negative 393.5. That's what's happening in my product. So I just want to make sure I factor in these coefficients. 0.5. When you guys do this, this should give you negative 1209.5 minus negative 1228.5 gives 19 kilojoules, which is going to be answer choice C. All right, so I'm going to move on to number 5. That's not number 5. Again, I'm not going to be doing number 6. We'll do that one in SI if you guys want, but again, you guys didn't go over that, so I'm going to cover that. 0.38 grams of silver in this equation here. So I want to start off with grams always, 6.38 grams of Ag. I want to convert that to moles, and 1 mole of silver has 107.87 grams of silver. And then here, what you guys want to do is see how are. So any element in its standard state is going to be 0, and he also tells you that it's 0. So let's find out what delta H is. Again, it's product minus reactant here. So again, you're right. And then you're going to want to do your waters. So here you have 2 waters, each valuing negative 285.8. I'm done with my product so far, and now I want to move it over to my reactants. For my standard state elements are 0, I'm only just factoring this H2S, which should be minus negative 20.6, and you want to multiply this by 2 since I have 2 in my equation here. So when you guys do that, that should give you negative 595.6 kilojoules per mole. And calculation, this should give you negative 8.79 kilojoules, and I'm just going to round that to 8.80. Again, you got a negative value, but all your answer choices are positive because it's already indicating that heat is going to be released for this one. much, Erica. Good point. So yeah, whenever you're doing any of these types of problems, we have to remember that even though we have calculated delta H as 595.6, 4 moles of this silver will make that much heat, 2 moles of H2S will make that much heat, and so on. Any questions on this one? No? Okay. Let's go on to number 7. Oh, where's the paper? All right. So for number 7, we are talking about bomb calorimeter. Here it says that a which increase in temp from 23.8 to 25.78. What's for the reaction? And the heat capacity of the calorimeter was 780. And it tells you the specific heat of water as well. It's either 4.184 or 4.18. Use as many significants as you are required. All right, so for this one, we have / reaction by not only the calorimeter, but also the water. So this is kind of a combination one that he gives you. QCal would actually be whatever is your calorimeter plus whatever is absorbed by your water, since we have both of these factors. So let's just find the calorimeter first, since it's kind of easier. So QCal is the heat capacity of the calorimeter times delta T. So this is going to be 96.04. And this is joules, degrees Celsius. We want to change this over to kilojoules, so this would be 1.1496 kilojoules. You just divide by 7. All right, now you want to know and the heat capacity of water. We can actually go and plug in this MCAT. So for mass of water, we have 4,560 grams. The heat capacity of water is 4.184 for this one. And your change in temp is going to, when you guys do this, it's going to be 3,558. And again, whatever is absorbed by our surroundings, which in this case is not only the calorimeter but also the water, we want to add. So when you do 36.558 plus 1.496, this should give you 38.05. Happens to your system. In this case, your system is your reaction, or what we're studying. So that should be a negative 38.056. And once you get to this part, after you have completed this long process, you want to remember how much of the sample you were burning. So I have 0.9 grams of C7H8, and I want to convert that to mole. 92. That does not look like a 92, but all right. So 92, and when you do this, you really have, and remember for delta E, it's just going to be QCal over mole. Negative 3 1,900 kilojoules per mole, which is answer choice C. Any questions on this one? This is probably the most complex one that you guys have. Number 11 is going to be the same. So, and then number 11 is this exact same concept. I just want to make sure that you guys have this so you can have a guideline for the rest of it. Any questions on this one? You good? Does anyone need more time taking pictures? Yeah. Uh-huh. So for delta E and delta H is usually just what's happening to your reaction over how much moles of the sample you have. So that's a good point. So if this is Q reaction. Because whatever happens to our calorimeter or our water or our surroundings, the opposite happens to our reaction. Q reaction. That's why, and also those concept ones. So it says which one to calculate delta H of the reaction. So we can obviously calorimeter, either bomb or solution calorimeter. We can use Hess's, use heat of formations. Number 6, I will not be going over that one today. That will be for SI. The only thing that we can't really the delta Q plus W is false. So I'm going to make sure that you guys have this little chart to remember for delta E. So I'm going to have my heat and I'm going to have my work. And we're going to say when it's positive or when it's negative. So if you guys see that the gas is being compressed or lowering in volume or work is done on the system or work is done by surroundings. That's kind of the little chart you want to have. Work is negative when a gas expands or there's an increase in volume or the system is doing work. Again, since I'm not going to be with you guys on the final, I just want you to think about this one, whether you're thinking about if work is positive or negative. That. So just kind of remember this terminology. And for number 9, it says which one's going to be false. So if heat is absorbed, Q is positive, that's true. If you're doing work, you're going to be negative, that's true. When you release heat, it's going to be negative. And if it's positive, then which is a positive, you're basically going to be adding heat. And then you're going to when you have an exothermic reaction, you're going to have your reactants, and then you're going to be releasing heat and making your products. So for this one, it's going to be D. Again, I'm not sure the depth that he went into with these two, but it's just kind of good to know because you do go over it in Chem 2 as well. All right, we're going to do number 10, and then again, if you guys can bring up the surveys and all have to remember that for work, this is going to be our equation, and then we have to remember that it's final minus initial. So some of us want to subtract that 5, but what we're really doing is 5 minus 50, and then we want to multiply it by our pressure, which is 10 atm. Per liter. That 1 atm liter has 101.3 joules. Considering that he didn't give you this conversion, I would kind of memorize it. If not, then he should be giving it to you. So when you're actually doing this, this gives you negative 45.5 joules. Or if you put that into scientific notation, that's negative. Again, number 11 is the same exact thing as number 7, so I'm not going to be going over that one. Again, if you guys can bring up your surveys, if you guys have any questions or quick remarks. If not, I'm going to be having my sessions on Monday, so make sure that you bring any questions